Hi, I'm Nick, and today I'm going to give you a little introduction to motion capture. Now, motion capture is taking a 3D representation of a person actually moving in real space and putting it onto a computer. This technology is used for many different things. It can be used for movies, video games, and simulations. In the movie industry, the latest movie, Beowulf, that just came out, a lot of it was motion capture. And the way you can tell is a lot of the movements are fluid. You have markers all throughout the body, and as they move, the cameras will pick up what's going on, and you can see all that in 3D space. And I'll be showing that to you later today. Video games, same concept. Take the movements, apply the animation in-game, so you have more realistic characters, more believable concepts. For simulations, it's a little bit different. For simulations, we can simulate having somebody doing CPR using the motion capture suit, so then the computer can actually say, hey, you're doing it wrong, or you should move your arms this way, and have it all controlled by a computer. So there's a lot of applications that motion capture is for. Now, I'm going to give you a quick little introduction to what each piece of the process is as far as the equipment that we use. Now, first of all, we have our owls. Our owls are these 12 cameras you see here. They're called owls because if you look at them, and they look like owl eyes, especially when you turn off the lights, you can sort of see a faint glow. It's a little weird, but cool. We have our 12 cameras. Each camera is doing at 480 frames a second. That way we can get as much data as possible. If we tune the system just right, we can actually see the individual heartbeat of a person just from the vibrations of the heart beating from our markers. Each camera's got 60 degrees field of view, starting from here. You're actually going to see that a little bit when I cue up the cameras. They come out in a nice little triangle, and we have it in a nice encircled area, so this way it's get the maximum view. And the view of it actually ends right about here, if you're on this side, and you just do a whole square all around. So the actor will mainly stand in the center, that's over here. Now, it also allows for unfiltered real-time data. Now, what that means is it takes everything and you see it live. There's no filtering, there's no pre-animation done to it. It's all raw data. With another system that's very popular to use in Hollywood, it's called Vicon system. They filter their animation before you and the animators can get it. What happens is that the character will do a little running motion, the server will pick it up, render it, and smooth it out, so it's not natural. The computer's already adjusted some stuff, so every now and then you'll see the leg just kink off, because it's filtered. With our system, we don't do it. We get the raw data, and we're able to put it in and then edit it afterwards. Now, what controls it is we have little markers. These are little LEDs, and you'll be seeing these on our model here, PIC. And these little LEDs here will blink at 480 frames a second as well. But they don't blink all at the same time. If they did, the cameras wouldn't be able to see it. What they do is they each blink at a different rate. Each marker has its own name, allowing it so that if I cover it up, pull it back over, the camera knows what it is. On the Vicon system, they have what's called a calcium ball system, and it uses light refraction. And they have the balls all over it. There's no markers to it. They have to individually go in there and say, we want this for here, this for here, this for here. So if I was to cover up my chest and then let go, you would see my chest disappear and not come back for at least 2 more seconds before the cameras go, oh, that was for that marker. With the LED system, each one of these LEDs has a specific name. So when I cover up and let go again, it will actually recognize it's still there and nothing will disappear. Now, what all the cameras are hooked up to is what we call Xavier, or server. The server is what controls everything. It filters it all in. It can control up to 24 cameras. It's Linux-based. Linux just provides the lowest amount of resources for the computer to use so that all the resource power goes to the cameras and rendering all this out for us. With this server, we're allowed to have a direct connection to just one PC or to the entire network. So if we want to put the server on the network and let 50 students have access to this data, we can. It has that power. Now, what controls the LEDs? This little guy right here. This is what we call the driver. The driver can control up to 72 LEDs at any given time. The average suit, PIC will come forward. You can see PIC in our suit. This one right now has about 42 LEDs. If we put the gloves, the head, and the feet on, we're probably about 64 LEDs total. Each LED is the marker, and it controls that. And this driver, I have one on her back that's right here. The driver there will tell the LEDs when to blink, how fast to blink, and also the interpolation. I'm going to talk to you a little bit about the interpolation. Now, what controls this driver is the LED base station. The LED base station is this guy right here. It's a wireless device that actually controls the timing of the driver. This allows the driver to be directly connected to the server at all times during capture. So the server knows what's going on and can control everything from there. Now when you put it all together, you have your server, goes down to your cameras goes to your server goes to your workstation, or your base station goes to the driver goes to LEDs. So all comes together pretty nicely. Now, what we're going to do is I'm going to show you a live demonstration of how to calibrate, how we use the alignment, and then you can see the end result of having our model live in 3D space. So what I'm going to do is I'm going to have Chad on the computer, and Chad, if you can just close that PowerPoint for me, please. Now go to calibration, excellent. Now, whenever we click connect, it's going to directly connect to the server at a specific IP address. And then once you go ahead and click connect for me, please. And what it just did is it activated the cameras. If you look on the side of the cameras, you'll start seeing the lights turn on and blinking. And then I'm going to turn on the driver, and the LEDs on here should turn on if I have it in the right port. There we go. So now the LEDs are active. Now if PIC shakes that fast enough, you can actually see each LED blinking at a different rate. And up here on the screen, you can actually see its point in space. So PIC, if I can have you stand in the middle, you're going to hold the stick with all LEDs facing out. You're going to spin in a circle. And once you're done spinning a circle, you're going to step out, still holding the stick in the center, and you're going to start walking around, making sure you keep the wand in the center. This way the cameras know what's going on. So if you click, 1 second, if you'll click capture for me, Chad, and you can start doing that. What this is doing is it's setting the field of view for the camera. So the cameras know it needs to look at this specific point. You just go ahead and walk in the circle, there you go. And then just step out one loop and then just keep doing the same thing. So like, there you go, now just come, there you go. And you can see up here, each little block is lighting up saying that, oh, hey, this is what's going on. Now, not all the blocks are going to light up because sometimes you just won't pick up. You may be out here too far before the camera will see it. But all we really matter is these little center blocks right here. That's the direct line of sight. So if you'll click calibrate for me, please, Jack. And what it's doing now is it's saving all the information, and now you can see the points in space, and it's passing all of its inspections. It's saying, okay, she moved this far, so it's moving the cameras up a little bit more, and then it just moved them up. Now it just recorded all of her movements, so you can see where the wand was actually at in the 3D space. So if we wanted to animate that, we could. So now, and Chad's just moving through, we can do that. Now the camera's like, okay, we're centered here, and you can see the cone that's coming out. Now, Chad, if you'll click on the calibration drop-down menu, it's right beside the connect, and go to alignment. What alignment's going to do is we're going to tell it where its origin is, its x-axis, and z-axis. So you'll probably need to face the screen this time, okay? When it says, when I tell Chad to click align, you're going to put the wand directly under the ground at the markers right below your feet. That's going to set the origin. And you'll see the screen green, flash green. It'll step forward once, lifting the wand, put it down. It'll flash again, that's the x-axis. Step back, go to the right, and that's your z. So Chad, if you'll click align for me, please. So step forward. Now back and then to the right. All right, and you'll just click save for me, please, Chad. And what this is doing is just save the origin, the x-axis, and the z-axis. So now the cameras know, okay, this is where everything is going to start, and now it has a point of reference as far as what's going to happen when it renders. So now, if you exit out of that for me, Chad, we'll go to master, please. Thank you. Oh, we need to unclick connect on the calibration. Thank you. Just go back to master. Now what I'm going to do is I'm going to turn this driver off, and I'm going to turn the driver on PIC suit on. If you'll click connect on master, driver's on, boom. So now on the screen you can see each individual point of space, so whenever she moves you can see her arms move, you can see her legs move. And everything's done. Now if we're going to use real capture for this, She can exaggerate her movements, so this way we can see it a little bit more clearly if we wanted to have it. So if she's throwing a side kick, she would exaggerate the side kick. If she's doing a little bamba, she'll exaggerate all the movements on there. And that is a quick introduction to motion capture. Any questions? Thank you.